Today, oh, by the way, there's parent-teacher conferences this week, so I think it's tomorrow night and Thursday night. So, and by the way, I don't care if you come with your parents or not. There was a point in my career where I cared, and I'm kind of past that. Anything I have to talk to your parents about, I will say just as openly as freely, whether you're sitting there or not. So it doesn't matter to me. If I were you, I'd probably campaign to just stay home. But like if you want to come and walk around with your parents, totally understand. So you're welcome either way. But it's Tuesday night, tomorrow night, and I think Thursday night. And then there is no Friday school this week. I believe the school district is completely closed on Friday. No school, no Friday school, no none of that stuff. It's yellow on the calendar, and that's always what that means. So I think that's my understanding. This lesson I don't think will take very long. It's just what takes a longer is the assignment that I have for you today, because when I wrote the assignment, I made sure, and I can do this by just building the problems from the ground up, that there are no numbers work. They're called integers, right? Like -2, 4, 1. There are none of those. So all the ones we're going to hunt for today are fractions. So I just want you to know going into assignment 14 that if you try things like 4 and 5 and 2, they're not going to work. And then throughout the week, I'm going to start giving you more problems where it's a mixed bag. Whole numbers might work, fractions might work, but today I'm really going to push the fraction issue on you pretty hard. So, and there's only 4 problems in the assignment, and that's just because in my opinion, they take a long time, unless you're, one of those guys, maybe. I don't know, but they should take a little bit longer, I think. So anyways, we have to talk about how to do synthetic division with a fraction, because if you can't use a fraction, then you can't find zeros like a lot of the time. I don't know what I was trying to say there. I did have a better thought than that, but my words failed me. So let's do 2x to the third. So let's do like f of x equals, my bad, I forget that a lot, plus x squared minus 25x plus 12. So just to save us some time, because I really want most of today to be you working and not me talking, I'm just going to tell you that this works. So the question now becomes, well, how do I figure that out? And it's really, those of you with good basic skills will be rewarded in an assignment like this, whereas those of you, like if I ask you what's 2/3 of 12, and it takes you longer than like 2 seconds to say 8, then you're someone who's going to struggle a little bit more. And I can go through some shortcut fraction-y kind of stuff. I have 4 examples. And if you have questions about how did you do that, I'll kind of show you how the human brain is supposed to calculate fraction multiplication problems. Calculator will do it, I get that, but it just makes you always slower than the guy or gal next to you. So you choose. So anyways, if I go into this now, and I'm not, this is no surprise, I'm telling you that 1/2 is an answer. So what I want to do is set it up for synthetic division. So we're going to put our 2, there's no missing terms, 1, -25, positive 12, upside down division thingamabobber, and we're going to put 1/2 out here. Oh yeah, got him. Got the fly. Anyone watching the recording is wondering they just killed the fly. Nope. All right. So the difference this time is I'm telling you that it works, whereas you will have to do these on your own. And as someone that I worked with this morning will testify to, it's very frustrating if you're making little mistakes because you can have the answer right in front of you and then miss it. And then you waste another 20 minutes of your life looking for things when you already had it right in front of your face. So this is how we do synthetic with fractions. It's the same process. You just have to be better with your basics. So I still drop the 2. And then I start to think in terms of now multiplying by fractions. One thing that's going to help you a lot is to change the word times to of. When you ask people what's 1/2 times 10, a lot of times they'll panic. Not most people, but a lot of people say, I don't know, I suck at fractions. But if you just walked up to some random person and said, what's 1/2 of 10? They all go, well, 5. What kind of stupid question is that? So when you think multiplication with fractions, think of. It will help you a lot. So what is 1/2 of 2? So I put 1 here, and then I continue the algorithm. So what's 1 plus 1? What's 1/2 of 2? It's very good. Put 1 here. What's negative 25 plus 1? What's 1/2 of negative 24? Negative 12. And so this is kind of how it's going to feel working with fractions. It's the same process of drop, multiply, add, multiply, add, multiply, add. But this time, again, we're working today only with fractions. And then, of course, you could finish the problem from there if I wanted you to, but we're not going to. Got it? This lesson is not about last week's lesson. You know how to finish. You know how to bring the numbers down, write a quadratic, factor it, and solve it. This lesson today is just about how do I navigate synthetic division with a fraction on the outside. So 1 down, 3 to go. Got it? No, you'll finish it. I'm just not for the notes because I feel like it would just be rehashing last week's lesson. Do you want to finish it? Would that make you, would you guys like that? Okay, let's finish it. So what I want to do is I want to take these numbers down now, the 2 as an x squared plus the 2x minus the 24. And just like we did last week, I want to set that equal to 0. And then, of course, you would notice that there's a GCF on the left side, right? So you would pull out the 2. And then what would that leave you with? Nice. And then, of course, from there, you would factor it down, and that would become 2 times x plus 4 times x minus 3. So your answers to this problem overall would have been, I'll write in green, x equals 1/2, because that was the one that I gave you. And that's one that you'll have to find on your own. So this, I don't want to spend today's lesson testing a bunch of things. I want to sort of just get in there and again practice with you the mechanical aspect of how to do a fraction. So the answers are x equals 1/2, x equals -4, and x equals +3, right? In your assignment today, assignment 14, there will not be any of these. I just wanted to write those for the lesson so the problems would look a little bit less ugly. Okay, good. And same expectation, you'll still be making a list. That's always going to be the expectation. When we're doing anything polynomial, rational, Rudy, we're always going to ask you to write a list of all possible rational zeros. So maybe to set a better example, I'll do that with you on this next problem. Got it? So here's example number 2. Let's do g of x. And he is 4x to the 3rd plus 9x squared minus 19x. So I'm going to do this problem exactly the way I would expect you to do a homework problem, except I'm going to give you, there's one part where I'm going to cheat in, again, to save us time for the notes. So step 1, let's make a list of all possible rational zeros. Remember, to do that, we have to take some combination of the number in back, the purple number, and the yellow number. So what are all the factors of 30? 1, 2, 3, 5, 6. And once you make one rainbow, if you guys ever learned factors this way, that's like a little rainbow, right? Once you make one, then you can build all the others. So once you get to what we call the center of the list, then you can pair 3. Who pairs with 3? Who pairs with 2? And 30. So that's, once you get to the middle, then it's a lot easier, I think, because then you're just completing math problems instead of searching. And then on the bottom, I need all the factors of the yellow number, which are 1, 2, 4. So if we were to make a list of all possible rational zeros, The first thing I'm going to do is I'm going to start with the number 1. So wherever my little arrow is pointing is where we're going to pull all of our possibles. So we have positive negative 1 over 1, positive negative 1 over 2, positive negative 1 over 4. Got it? And now I'm going to move my arrow over to the next guy, and it's 2's turn. And you're going to see a lot of repetition throughout this list because we have so many even numbers with even numbers on bottom. So there's going to be a lot of repeats. So the first one is positive negative 2 over 1, which is new. The next one is 2 over 2, which is already done. The next one is positive negative 2 over 4, which is done because that's a half. So 2 is done. So let's head over to 3. I'll switch to a little red arrow if I can figure out how to work my software. There it goes. Good. So the first one is positive negative 3. And as I said this in last week's lecture, you'll see more uniqueness when you start dealing with odds and evens, right? They're not as repetitive. And the next one is positive negative 3 over 4. So we're more than a third of the way done with our list. Next one, I'll move the arrow over to 5. I'm ready, okay. Next one. Next one. Good. And there's going to be a lot of repetition, and you know that on this next one. Why? Why is the next one going to be full of, not full, but a lot of repeats? A lot of evens, right? So I see the 6s and 2s and 6s and 4s blending to create things that I've probably already seen before. And I'm not going to do this, by the way, for the rest of the examples. I just thought, let's do this one so you're clear. This is still part of the job. So the next one would be positive negative 6 over 2, which is a repeat, and then 6 over 4, which reduces to 3 halves, which is also a repeat. So we can head on to the 10. Tristan was hopping ahead of us there. This is good. Positive negative 10 over 1. What's the next one? 10 over 2, 5, done, right? Next one is 10 over 4, 5 halves, done. So we can move on past the 10. Let's head over to the 15. So we have positive negative 15. Positive negative 15 over 2. I'm officially going to run out of room. Despite my best planning, I ran myself out of space. Dang it. And the next one is positive negative 15 over 4. Maybe I can squeeze this in. I think I only have one more new one. Positive negative 30. And I think I made it. Hope I can just can barely see him over there. Yeah, because 30 over 2 is done. 30 over 4 is done. So that's the list. So your job today is going to be to pair off again. I assume you're working in small groups on this, and you'll search. And I'm just, to save you time, I can tell you that the winner is somewhere in there. So the what we're looking for is negative 5/4, and you would have had to find that on your own. So I'm telling you, let's get our numbers lined up for synthetic. So we have 4, 9, negative 19, negative 30, and we're going to do our upside down division thingy. And the winner is negative 5/4, and I know that because I wrote the problem. So I have that the advantage here, clearly. All right, so don't be scared. Again, basic skills, people, I am sorry in advance for what you are about to have to go through. So we're going to drop the 4, and here we go. So this is where we need to stop. And if you don't get this, if you just ask me to go over it a couple times, no one will judge you, okay? But does anyone know quickly what negative 5/4 of 4 is? It is negative 5. And if you're unclear on how that worked, I'll just show you, even for anyone who doesn't want to ask. And if this isn't enough, just ask again. When I do negative 5/4 of 4, I think in my brain of 4 is 4 over 1. Like, this is a very mathy explanation of this. And then do you see how the 4s cancel? Yeah. And that's where we got negative 5. Another way to think of it is this. This is the way I used to teach fractions. If someone asked me for like 3/4 of 12, my brain calculates 1/4 of 12, which is 3, and then it triples it. Because if you want 3 of those, then I'll just triple what I got. Like, what is 5/6 of 18? What's 1/6 of 18? It is 3. So what's 5/6 of 18? 15. If you can find 1/6 of something, then you can alter that answer to find 2, 3, 4. You just take whatever you got and multiply by how many you want, right? Okay. All right, let's head on. Let's keep going. Coming on down the way, 9 minus 4 or 9 minus 5 or 9 plus -5 is just 4. And look, it's the same problem again, so we know we're going to get another -5. Add those together, what do you get? -24. So on this one, there's kind of two sides to this problem now. Number one, don't mook it up by forgetting about your basics. What's a negative times a negative? So let's not put a negative here, and let's just focus on the math. What is 5/4 of 24? It is 30. Because, and again, it depends how you set this up. If you want to do this very literally and very mathy, you can think of it as 5/4 of 24 like this. And then you see the hook, how the 24 divides by the 4 to get 6. And then you multiply by 5, and there's your 30. So again, we have the luxury on that one of like, well, duh, Mr. Ahern, you told us it was going to work, so I knew this had to be a 30, but you're not going to have that luxury when you're doing this by yourself, right? So that works. And then, are you okay if we don't finish this just to get through this? Is that okay? Yeah. Like we finished the first one, but you get it. Write it down, GCF, factor it down. You got this. Okay, let's do another one. Let's call this problem h of x. This function is h of x. And he is going to be 3x to the third minus 4x squared minus 28x minus 16. Let's make a list of all possible rational zeros. So what are the factors of the number in the back?
1, 2, 4.
Right, and 4 counts as the center of the list because 4 times himself would make 16. So that's how I know I can start building the rainbows across the way, right? And then what are the factors of the number in the front? 1. Yeah, so this is a much wimpier list than the last time. So if we were going to make a list of all possibles, we say positive, negative, 1 over 1, positive, negative, 1 over 3. Positive, negative, 2 over 1. Positive, negative, 2 over 3. Positive, negative, 4 over 1. Positive, negative, 4 over 3. Why is there not much repetition in this list? The tops are almost all evens. I mean, they are all evens from here on out, and the bottoms are all odds. And so there's a lot of lack of cooperation here, right? So next up is positive, negative 8 over 1, positive, negative 8 over 3, positive, negative 16 over 1, and positive, negative 16 over 3. That's not that bad. Only 20. So what would you guys like to try? Positive 2/3 it is. So let's take, and just again, be organized, be meticulous about what have I and have I not tried, because it can get really out of your hands if you're not organized, if you don't keep good track. And Bryce said he wants to try 2/3. So let's put a 2/3 out here, and we are off. Drop the 3. What's 2/3 of 3? So we put a 2 here. Add those together. What's negative 4 plus 2? Negative 2. What's 2/3 times negative 2? It's negative 4/3. Okay, now you have to add negative 28 to negative 4/3. What's that? Negative 29 and 1/3, which is negative 88/3. I'm gonna probably have to talk about that here, right? When I just did this problem right here, you should not have enjoyed that problem right there with the green arrow. You can think of it a couple different ways. One very common way is to take the negative 28 and think of it as negative 28 over 1. But then you have to give it the same denominator. So how do you make something have a denominator of 3? You multiply it by 3. So what that really is negative. So I think I might have messed up my math here. Did I mess up my math? 3, 4? I don't think so. That would be negative 84 thirds, right? And then add those together. That's okay. Okay. Another way to do it, if you were listening to me as I thought out loud, is I thought of this right here as minus 1 and 1/3. And then I added negative 28 to negative 1 and 1/3, which is negative 29 and 1/3. And then I just converted it back to an improper. You kind of have to pick and choose. Or if you're just one of those calculator people, then you're just like, whatever, don't care. And then we have to multiply, and this is getting out of hand. Can you already tell this is probably not going to work? Yeah. And if you want to finish it out, you can. But honestly, what I feel like with these, and I remember this from when I learned this, is that as soon as I hit fractions early, I always kind of thought, it's not a guarantee, but I always felt like I should go a different route. Like, because now I have to multiply 2/3 by that, and I'm going to get negative 176 over 9. How do we know already that that was not going to work? What would the red number at the very end, the last red number I wrote, what would it had to have been for this to even have a shot? Positive. Thank you for saying that. If it's not positive, it's not going to work. So, I mean, that one was out of the running. So what else would you like to try? Sure. So 4/3 it is. All right, so drop the 3. What's 4/3 of 3? 4. So put a 4 there, add those together. What's 4/3 of 0? 0. What's negative 28 plus 0? Negative 28. And how can we already tell to stop? It's going to be a negative number. If you take the purple 4/3 and multiply it by the brand new negative 28, what is a positive times a negative? Is a negative, so we know it can't work, right? So you can stop there. What else would you guys like to try?
16.
Say it again.
16.
16/5. 16/3. The air conditioner's on behind me, so I apologize. My ears work really well, but that thing, you can't hear it, but it just hums. Yeah. Huh? All right, what's 16/3 times 3? All right, so we'll put 16 here. What's negative 4 plus 16? 12. What's 16/3 of 12? And again, you want to get good at this. You want your brain to see it. So let me walk you through how my brain does it. I take this number 12 and I divide it by 3. Can I do that? I get 4, and then I multiply it by 16 and I get 64. Then add those together. What's negative 28 plus 64? 36. All right, so this one is at least in the running, I feel like. It's not going to work, but it was a good shot because it felt good all the way to the end. And I'll circle things. What is 36 divided by 3? 12, and 12 times 16 is obviously a little much, 192. So that's not going to work. But hey, at least we got something that felt smooth and good vibes all the way to the end. And it was a positive and all that, just way too much. You want to try 8/3? Sure. Yeah, I noticed that hasn't really been a popular idea yet. Everyone's really sticking to the positives. So I'm just going with whatever you tell me. I know the answer. I wrote it. So drop the 3. What's 8/3 times 3? 8. Add those together. 4. Right. And so we're already going down that dark road where we start to feel that thing, right? We're going to get 32 over 3. And this is already just feeling pretty bunk. Like, by the way, if you have negative 28, that's way more negative than 32/3 is positive. 32/3 isn't even 11. It's 10 point something. So this is going to be a negative. which means this times this is going to be a negative. My logic tells me I can stop there. Okay. What else would you like to try? Okay. Drop the 3. What's negative 4/3 of 3? Negative 4. Add negative 4 and negative 4. Get negative 8. And here comes trouble, right? Trouble ahead. What's negative 4/3 times negative 8? Positive 32/3, right? And again, this would be a good time to think common sense. You have to have a good number sense, right? Negative 28 is very negative. What is 32/3 close to? 10 or 11, right? And so if you add negative 28 and something that's not even 11, you're going to get, again, logic says I'm going to get a negative here and a negative here. So I think maybe I can press on because that's good, right? A negative and a negative is going to make a positive here. And that's what I want. So it's okay to press on in this case. It's ugly, but maybe it will yield some fruit. I don't know. Are you just telling me to start over? It's okay if you want me to. Do you guys want me to start over? Okay, good. So this is the process that you guys are going to undergo. And I realize that you might not think it's all that awesome, but the challenge obviously has elevated quite a bit because, yes, this does work, by the way, you found it. It's harder to find and they're harder to test. Right? That's what makes it harder to find is because the tests are like, they're harder. So let's work through to verify that, yay, good job, Tristan, good job, Blair. Anyone else that found this, good job. What's negative 2/3 of 3? It is negative 2. Add those together, what do you get? What is negative 2/3 of negative 6? It is positive 4. And again, I just need to keep walking you through this. You should look at the TV while I do this if you're struggling. Don't get ahead of me, please. Take your whole number, divide it by the bottom. Forget the negatives. Just what's 6 divided by 3? What's 2 times 2? So that's the process that you should be going through. It's the hook I taught you back in Algebra 1, how we kill fractions. We divide and multiply, divide and multiply. That's all we're doing there. Except just, of course, it's positive. What's negative 28 plus 4? Do the hook again. 24 divided by 3. 8 times 2. Negative times a negative. Jackpot. And then, of course, from here, once you get that first sweet feeling of success, then you take these numbers down, set it equal to 0, put your mad skills to use. Of course, pull a GCF out because, like, not pulling out a GCF is just weird. And then factor. So let's do one more, okay? You guys get the idea? Okay. Last one. This will be, what have I used so far? FG, did we do H already?
Yeah.
Let's do J of X. Why not? So J of X is this function. Do you see why there's potential for repetition here? Just, I'm curious to see if you would spot this. What's a common factor of 6? And what's a common factor of 15? 3. So the fact that there's some commonality means we might see quite a bit of repetition here. So the factors of the number on top are 1, 2, 3, and 6. The factors of the yellow number on bottom are 1, 3, 5, and 15. So here we go with our list. We have positive negative 1, positive negative 1/3, positive negative 1/5, positive negative 1/15. All right, on to the 2. Yeah, I might have just straight lied to you here. There's going to be a little repetition, but not a lot. So next up is positive negative 2, positive negative 2/3, positive negative 2/5, and positive negative 2/15. Next up, positive -3. And then there's 3/3, which is accounted for. Next up is positive -3/5, which is not accounted for. And then after that is positive -3/15, which is accounted for because he's 1/5, right? That leaves us then with number 6 on top, and he's going to be positive negative, of course, 6. You'll never hit repetition with ones because that's always going to be a new unique whole number guy. What is 6/3? 6/3 is 2, which is already on the list. Next up is 6/5, which has to be new. And then the last guy is 6/15, which reduces to what? 2/5? That's already on the list. Just to save us some time, because I would like to let you work today, why don't you guys just keep guessing fractions and I'll tell you when you get it. Nope.
-1,
Nope. Nope.
positive 2.
Yes. 2/5 is the one that you would have had to find. And honestly, there are some others, by the way. 1/3 would have also worked. And actually, I wrote my examples a little wimpier so that they would go a little quicker. But yes, the one I was hoping to find is 2/5. So here we go. Let's synthetically pop it in, practice one more time, and then it's your turn. So we have 15, 34, -31, positive 6, upside down division thingamabobber, and 2/5 is our guy. Let's do this. Oop. All right. What is 2/5 of 15? It is 6. What's 35 plus 6? That'd be 40, right? What's 2/5 of 40? 16. -31 plus 16? -15. For this last one, bear in mind it's a positive times the negative, so maybe just put the negative sign down so you don't forget. Do that first. 15 divided by 5 is 3 times 2 is 6, -6. As advertised, it works. So that's what we're up to today and probably tomorrow. We'll see how long, couple, at least 2 days on this idea here. So any questions? Yeah, your answer should consist of the listing of all possible zeros and then the listing of the actual zeros that work. Yes, got it. Cool.